Hi everyone, this is Ankit from EcoSikho, and we are here to discuss straight lines. Chapter number 1 in your IB course syllabus. So let's get started. Okay, so what are we going to cover in this video? We are going to talk about lines in the Cartesian plane. We are going to talk about graphing a straight line. We are going to look at perpendicular bisectors. And finally, we are going to wrap up by discussing how to solve simultaneous equations. So first of all, what is a Cartesian plane? Okay, so Cartesian plane is a plane that contains two axes. You have a x-axis and you have a y-axis. That's your Cartesian plane. Okay, so this one over here is the x-axis, and this one over here is your y-axis. Okay, so in a Cartesian plane, we are gonna discuss about straight lines. Okay, so how does a straight line looks? It may look like this. So what is a straight line? Basically, a straight line is a line that does not contains any turns, that does not contains any curves. That's a straight line. Okay, so what are we gonna look at? We are gonna look at how can we make the equation of the straight line. Okay, so before jumping into that, the straight line that you can see over here, let me name it L1. This straight line, it is cutting the x-axis at a point A. Let's name it A. And it is cutting the it is cutting the y-axis at point B. The point where it cuts the x-axis is known as your x-intercept. So this is your x-intercept. And the point where it cuts the y-axis is known as your y-intercept. Okay, fine. So every straight line has some kind of a gradient that it makes with the x-axis in an anti-clockwise direction. What I mean to say is that the straight line L1 that you can see over here makes some kind of a gradient with the x-axis in an anti-clockwise direction. That is what we called as the slope of a line, or that is something we called as a gradient of a line. Mathematically, we represent the slope or gradient using the alphabet n, small n. Okay, so how can we find out the gradient of a line? The gradient of a line is equals to y2 minus y1 upon x2 minus x1. What are x1, y1 and x2, y2? x1, y1 are the coordinates of point A or any other point. So let's say if you have been given a random line that may not pass through the axis, okay, and we have been given two different points. Let's say this is point C and this is point D. And we have been given the coordinates for point C as x1 comma y1 and x2 comma y2. So using this two information, we can find out the slope of the line that has 2 points C and D. Okay, I hope that is clear. Okay. Alternatively, you can also say that the slope, that is the n, can be found out by y steps upon x steps. What is this y step and what is this x step? Y step is, let's say, this. So if in your graph, you can see that for B, it is 2, and for A, it is, let's say, 3. So that is another way through which we can find out the slope. For Y, it is going 2 steps, and for X, it is going 3 steps. So your slope will become 2 upon 3. So I hope that is clear on how we can find out the slope for a line or the gradient for a line. Okay. Moving on, if two lines are parallel, then their slope has to be the same. Their gradient has to be the same. So if you have got two different lines and you want to check if they are parallel or not, what we can do, we can find out the slope for these two lines and we can check if the slopes are same. We can conclude that these two lines are parallel. If the slopes are not same, then these two lines are not parallel. Similarly, how will you confirm if two lines are perpendicular to each other? If m1 m2 is equals to -1. Now, what is this m1 and what is this m2? M1 is the gradient for the line 1 and m2 is the gradient for the line 2. So if you multiply the gradients of these two lines and if you get the product as -1, then we can confirm that indeed these two lines are perpendicular to each other. That is, they are making an angle of 40, they are making an angle of 90 degrees between them. Okay. Let's talk about how to make the equation of a straight line. So to make the equation of straight line, we have many different ways. The first way is what we call as a point gradient form. So just now we saw the formula to find out the slope or the gradient of a line. That was y is equals to, sorry, not y, n is equals to y2 minus y1 upon x2 minus x1. What I can do is that I can rearrange everything, and after rearranging, I will get y minus y1 is equals to m times x minus x1. And this, my friend, is the point gradient form. So, sir, how can we use this point gradient form? To use this point gradient form, you need two information. You need to know what is the point. You need to know any point in the straight line, and you need to know the gradient. So let's say if I have been given the gradient for a line is minus 1 by 3, and that line passes through the point 2 comma 4, and I need to find out the equation of the straight line. So what I can do, that instead of y1 I will put 4, instead of m I will put minus 1 by 3, and instead of x1 I will put 2. And finally, after rearranging, I will be getting 3y minus 12 is equals to 2 minus x. Or I can say that x plus 3y is equals to 14 is the equation of the line that has a gradient of minus 1 by 3, and that also passes through the point 2 comma 4. So that was the first way of writing the equation of a line. Then there is this also gradient intercept form. Using this gradient intercept form, I can say that the equation of the line will look like y is equals to mx plus c, where this m is the slope and this c is your y-intercept. Okay, please remember this is your y-intercept and not your x-intercept. Okay, so that was the gradient intercept form, wherein I have been given a gradient and I have been given a intercept, and that intercept is the y-intercept. Okay, so let's move on to the third one, which is the general form. So in the general form, I can say that the equation of a line is ax plus by is equals to d. And over here, all of these a, b, and d are your constants. These are your numbers, fixed numbers. From this general form, I can conclude three things. First, I can conclude about the slope. The slope will always be minus a by b. Secondly, I can conclude about the x-intercept. To conclude about the x-intercept, I can say that my x-intercept is d upon a. And third, I can conclude about y-intercept. The y-intercept over here will be d by b. So these are the three things I can derive from the general form. If I've been given an equation that looks like ax plus by is equals to d, I can say that the slope will be minus a upon b, where your a is the coefficient of x and b is your coefficient of y. X-intercept can be found out when you put the value of y is equals to 0. So if in this equation we put the value of y is equals to 0, the x-intercept will be d upon a. And similarly, for the y-intercept, we will put the value of x is equals to 0. So that will give me d upon b. So these are the three things we can derive from this part. Moving on to perpendicular bisector. So what exactly is a perpendicular bisector? Okay. So let's say I have been given a line, and in this line I have 2 points, that is a point A and point B. I have been asked to find out the perpendicular bisector of this line segment. So, as the name suggests, I need to do two things. I need to bisect this line, and then the bisect part needs to be perpendicular to the original line. So, I need to find a point in AB so that that point divides AB into equal parts. And from that point, I need to draw another line that is at a 90-degree to the original line. So this line that we can see now is my perpendicular bisector. Let's call it PB for the time being. So these are the things I need to do. Okay. So let me take some random example. Let's say for this perpendicular bisector, I have been given that A has a coordinate of 2, 3, and B has a coordinate of, let's say, 7, 8. and I've been asked to find out the perpendicular bisector. I've been asked to find out the equation of the perpendicular bisector. So first, I need to find out the value of the midpoint, the coordinates for the midpoint, the point where M is at equidistant from A as well as equidistant from B. So how can I find out the coordinate? The coordinate can be found out by 2 plus 7 upon 2, comma 3 plus 8 upon 3. So L is equals to 9 upon 2, comma 11 upon 3. 11 upon 2, it should be 2. So these are the coordinates for point N. Okay. Next up, I need to find out the slope of the line AB. So let's find out the slope of the line AB. So it will be y2 minus y1, that will be 8 minus 3 upon x2 minus x1, that will be 7 minus 8. So 8 minus 3 will give you 5, and 7 minus 2 will also give you 5. So that's 1. The slope of the given line is 1. We know that the slope of the given line and the slope of its perpendicular, the product of these two lines will give you 1. Okay, so the slope of AB into the slope of PB should give you minus 1. So instead of AB, I can write 1 into slope of PB will give you minus 1. So from here, I can conclude the slope of the perpendicular bisector line for this particular example is minus 1. Okay, so to construct any line using the three methods. So over here, I have two information with me. I have the slope of the given line and I have a point through which the line passes. So I can very conveniently use the point gradient form. So what does the point gradient form tells me? The point gradient form tells me the equation of the line will be y minus y1 is equals to m times x minus x1. So instead of y1, I will plug in the value of 11 by 2 here. Instead of m, I will plug in the value of minus 1. And instead of x1, I will plug in the value of 9 by 2. So that's the answer. That's how we find out the slope of the perpendicular bisector. And that's how we find out the equation of the perpendicular bisector. So I hope that is clear with you. So what exactly do we mean by simultaneous equation? Why do we solve them? And after solving them, what exactly do we get? Okay. So guys, let's say I have been given two different lines. Okay. This is a random line that has a equation x plus y is equals to 9. This is another random line that has a equation x minus y is equals to 5. So what I mean by simultaneous equations is that I have been given two or more equations. Okay, and these two or more equations represent two or more different straight lines. And when I try to solve them, it means that I am trying to find out the point where these two lines intersect. Okay, so simultaneous equations means solving the two equations to try to find if the two lines are intersecting or not. And if they are intersecting, at what point they are intersecting. Okay, so you might be having some questions like, sir, is it necessary that these two lines will intersect? So let's look at a few certain scenarios. So let's say the equation of the first line is ax1 plus b1y is equals to c1. Let's make it equals to c. And the equation of the second line is a2x plus b2y is equals to c. Okay, so what happens is that if a1 by a2 is equals to b1 by b2, then we say that this line is coincident. This line, these two lines, they lie on top of each other if this is the scenario. But if a1 by a2 is equals to b1 by b2, then we say that these two lines are indeed parallel to each other. And finally, if a1 by a2 is not equals to b1 by b2, then we say that these lines are intersecting. Okay, so if two lines are coincident, that means how many different solutions are there? How many different values of x and y are there so that these two lines will meet? You will say that there are infinitely many solutions. So if two lines are coincident, we will say that there are infinitely many solutions. If two lines are parallel to each other, they will never meet at a single point. So there are no solutions. And two lines are intersecting with each other, then we will say that there is a unique solution. Okay, so that is how we can investigate two different lines. I have to look at the coefficients of x, y, and the constant terms. Okay, so what all different techniques do we have at our disposal to solve these two equations? So we have the method of substitution or elimination, or what you can do, you can simply graph these two lines using your graph paper or maybe using your calculator, or you can use technology, that is your graphic calculator. Okay, so in this video we are going to cover only the first one. Okay, so let's look at the method of substitution or the method of elimination. So solving the same question that I have written here, x plus y is equals to 9 and x minus y is equals to 5. Okay, so let's say if the two lines or if the two systems were x plus y is equals to 9 and x minus y is equals to 5. So what I need to do, I need to make sure that I cancel at least one thing. So let me add these two equations. So if I add these two equations, x and x will become 2x. Y minus y will cancel out. And this 9 plus 5 will become 14. So from here, you are getting x is equals to 7. And if you put this value of x in any of these equations, you will simultaneously get the value for y. So you will get y as 2. So that is the method of substitution or method of elimination. Okay, let me take another example. Let's say if the two lines or if the two systems were 2x plus 3y is equals to 9 and 7x plus, let's make it minus 5y is equals to 2. So these are the two equations and I need to solve it. So I cannot simply add them or subtract them. Why? Because I will still be left with something in the form of x and y. So what I will do, I will take the LCM of any one number, of any one coefficient of maybe let's say x or maybe let's say y. So let me look at y. Okay. So for the y, I will multiply this first equation by 5 and for the second one, I will multiply it by 3. The entire equation will get multiplied. So I will have 10x plus 15y is equals to 45. And for the second part, I will have 21x minus 15y is equals to 6. And next, I will add these two equations. So 10x plus 21x will give me 31x. This 15y minus 15y gets cancelled off. And this 45 plus 6 will give me 51. So from here, I can say that the value of x turns out to be 51 upon 31. And to find out the value of y, you simply substitute this value of x in any equation. You can choose equation 1, you can choose equation 2, that doesn't really matter. Okay, so that was how we solve simultaneous equations and how we find out if these two different sets of lines, if they are intersecting or if they're parallel or if they're perpendicular or if they're meeting. Okay, so that is all for this video. I hope you have liked the content of this video. I will be uploading chapter number 2 from your IB core topics very soon. Till then, stay safe, take care, bye bye.